Good afternoon, everyone. This is Kusuma from Team Victoria, and we are here today to explain about the topics input devices, user interface, and VR environments. And these are our team members' contributions. And I'm going to explain about the input devices, big correlation, and Chandrahas will be explaining about the input modes, interactive picture design, and Sriram will be explaining about the virtual reality environments, and Soumya will be explaining about the virtual reality applications and the user interface issues. And finally, Pratham is going to explain about the user interface issues, and then the part two, which is about the graphic designs and the examples related to it.
Mm-hmm.
And coming to the technical details now, the input devices. Usually, input devices are in computing technology, it is considered as a piece of equipment used to provide the data and to control the signals to an information processing system, such as a computer or any information appliances. And these input devices, for examples, like include the keyboards, mouses, scanners, cameras, joysticks, and the microphones. And in particular, we have two different ways to look into these input devices, mainly physical devices and the logical devices. Here, the physical devices in this computer graphics refers to the actual hardware components or any equipment that are used to display or manipulate the graphical context. And these physical devices are in particular to be like the tangible, and they're responsible for any of the physical aspects that are going to be done in this rendering graphics. And coming to the logical devices refer to the software abstractions or any virtual entities that interact with these all physical devices to create and manage the graphical content. And understanding the basic distinction between these physical and logical devices is very essential for developing and managing the computer graphics applications. And now coming to the origin of the input devices here, uh, mainly the input devices are being classified logically based on the three categories here. The first one was the modality of the input, and the other one is the input which is discrete or continuous, and the other one is the number of degrees of freedom involved. And in particular, going to the logical classification of these input devices, here we explain about graphic programs which require various types of input data in order to make graphics packages independent of the hardware devices used. These input functions can be designed or created based on certain data descriptions, which are need to be handled by each function. And this whole process results in the categorization of the logical classification of the input devices. And mainly, these are classified into 6 logical classes. And first one was the locator, and it's the coordinate position like X, comma, Y to move the screen to move the cursor to a particular position on the screen. The examples we consider for these locator devices are like mouse, keyboard, trackball, spaceball, thumb wheels, and some digitizing stylus or tablet. And these other cursor positioning devices are commonly used for locating a specific coordinate position on a screen. When the screen cursor is in the desired location, then a button is activated automatically to say the screen points coordinates. And to locate a particular coordinate position on a screen, we use a locator device. And the applications for these are the interactive drawing and editing applications, and we use in graphic digitizing. And these are the examples for it. And coming
Mm-hmm.
to the stroke device, these are used to input a sequence of coordinate positions. And here, many multiple calls to a locator devices will happen that are equivalent to a stroke device input. And here, The sections are frequently displayed using the set of input points we take. Here, the most commonly used stroke device was the tablet, which is used to, I'm sorry, which is used to take a series of coordinate positions as an input. And here the locators, such as the mouse and joystick functions, are used as stroke devices. And these stroke devices are most commonly found in the paintbrush systems, which is an application of it. And these are the examples for the stroke devices.
Mhm.
And coming to the choice devices, here we make a selection from a particular number of options. And here menus are used in graphics packages to select programming options, parameter values, and object shapes to be used in the creation of a picture. And then here, in particular, a choice device is the one that allows users to select from a list of options as a standalone choice device units, a function keyboard or a particular button box are designed. A choice device is typically a set of buttons or a cursor pointing device. Here, when a coordinate x comma y is chosen, it is compared either vertically and horizontally uh, at the coordinate values, for example, x minimum, x maximum, y minimum, and y maximum. And the option is chosen here if the x comma y function satisfies all the inequalities like x minimum, which is equals to the x maximum values, and then the y minimum is y maximum values. The whole point is here, it is used for the selection of uh, the selection happens from a list of options. The examples are the mouse, keyboard, touch panel, and the applications are interactive menu selection and program control. And these are the examples for it. And coming to the picking device here, the picking devices are used to select parts of a scene that are to be transformed or edited in some way. Here, mainly the cursor, which is a positioning device, use it as the picking device. With a mouse or a joystick, we can position the cursor over the primitives like the x, comma, y coordinates in a displayed structure and press the selection button. And this position of the cursor is recorded and several levels of search. Now, for the cursor coordinates x, comma, y, and the line endpoints x1, y1, and x2, y2, for example, decodes the function as x equal to x2 minus x1 and decodes function dy equal to y2 minus y1, which are calculated for many identification schemes. And the examples for the picking device was mouse, cursor, keys, and tablet. And the applications are interactive editing and positioning as well. And these are the examples for it.
Mhm.
And now coming to the pick correlation concept, the program must be precisely determined where in which the button, any icon or any item will be selected from the screen when a user pushes the locator button to that particular location in order to reply accordingly. And this particular choice is known as a pick correlation, and it is a very crucial component of the interactive graphics. Here, we discuss the methodology and of the pick correlation. And here, we in the beginning, we recognize the point where the cursor is placed and the object that the user is selecting a particular application using sRGP packages which executes the resultant pick correlation. And this particular pick correlation that we obtain so far is done by simple and frequently used Boolean functions, help, and all these tools which are used and the functions used are needed for this pick correlation, which are included in the GEOM packages. And here the sRGP is the simple raster graphics package, and the whole methodology has is explained in detail by my next teammate Chandrahas.
Pick correlation is a process where it determines where the cursor or the user has selected. So how do you determine if the user has selected, let's say, a label in a menu or something in a drop down? So when any user clicks on any object, anything, so the application creates a unique object for it, and that object is passed on to the pick correlation function, where based on the object, it determines what was the user interaction. So and let me go to the pick correlation function. So this is a pick correlation function, high level interaction handler. So if you can see, it takes a measure of locator input, which has the position where the user has clicked on the screen. So first, let's say when a user interacts with the pull down menu, so first it takes some the position, and based on the position, it determines where the user has clicked on the menu bar, and it gets the menu ID over here. And if the menu ID is greater than if it's a valid menu ID, then it performs the menu interaction ID and it selects on the label. But if the interaction if it's not a valid ID, it performs a different action. So it goes to a else part of the code where the user pegged within the drawing area detect and what to respond. So if it's not in the menu bar and it is clicked outside the menu bar, then if it's within the drawing area, it determines the position and it finds the object of it and we process the object. I'll give introduction to input devices. So graphical input devices play a crucial role in providing input to the applications. They typically provide two entities. They are measure and trigger. So the measure, it's like one or more characters from a keyboard, or it's like position of a locator device like a mouse or touchpad. And trigger is indicating that the device is available. For example, user has pressed enter on the keyboard, or user is using a mouse and it clicks on it. So the trigger indicates that the device is ready available. And in addition to the various type of logical input devices, we can obtain a measure of device in three distinct modes. They are request mode, sample mode, and event mode. So coming to the request mode, in this mode, the measure of the device is not returned to the program until the device is triggered. Uh, for example, you have a mouse and that can be moved to different points in the screen. And when, let's say, the Windows system continuously tracks the pointer location, but actual location is not written until the user clicks a button. So uh, and I'll explain. So we have a small diagram over here. So so the trigger process, user is trying to select something, and after selecting something, the measure process requires the program, and the application d- does what it has to do and sends back the measure. So here the measure process again, yeah, this is the request mode. So uh, and until the user clicks on it it is not device is not triggered. But and we have the second is we have sample mode. In this, input is immediate as soon as the function call is and the user program is encountered. Uh, uh, yeah. For both request and sample modes, the user need to identify which device provides input. For instance, the request underscore locator is a function uh, which is a request that is this function is called when a process uh, like a user does something, and here the input is immediate. As soon as a function call is done, it responds back. And coming to the third mode, it's event mode. And in the event mode, each time a device is triggered, an event is generated and placed into an event queue. From here, there are two common approaches. The program then retrieves event from the queue and processes them. Alternately, you can associate a callback function with each specific type of an event. When that event reaches the front of the queue, the associated function is automatically executed. So these are the three types of input modes, uh, picture generation. Uh, Graphic packages incorporate various techniques to facilitate interactive construction of pictures. These techniques provide different input options for entering coordinate information, making the user experience and graphic construction more accessible. So we will explore the following basic positioning methods, and there are two major categories. One is the basic one, and we also have a rubber band methods, which also has straight lines, circle lines, rectangle, free form curves. Yeah, the next slide. So this is the basic positioning method. Basic positioning method are fundamental for accurate graphic construction. These methods involve specifying the location of the field points in a picture. For example, if you want if you want to place a point at a specific coordinate x comma y, you can directly input those values. This provides precise control over the placement of graphic elements. Uh, the same is shown on the screen on the picture. So a position cursor and a press on a button, and and the object is displayed at the cursor position, and press button to select the position. You select the position, and the text is displayed at the center of the position. Coming to the rubber band methods, in rubber band methods, we have straight lines, circle lines, rectangle, and freeform curves. Um, so first, I'll explain about the straight lines. Straight lines are often more common geometric elements in graphics. They are constructed by specifying 2 points, the start and end coordinates. This creates a line segment, such as a line between 2 points, providing simplicity and precision in creating lines. Uh, the image also explains the same. First, you start clicking on a button, and you'll select the endpoint. After that, the button is you release your cursor, and it creates a straight line. Uh, Coming to the circle lines. Circle lines are used for creating circles and arcs. To construct a circle, specify the center point and its radius. For arcs, you can define the start and end points along with the center to create a circle segments or arcs. So the image is the same. You press button to start it, and you stretch it, and you stop the button, and it creates an arc. Or you for creating a circle, you can specify a center point and its radius, and it creates a circle line. And this rectangles are essential for defining boundaries and shapes. They are constructed by specifying two opposite corners of the rectangle This provides an easier way to create a square or rectangle. Uh, First, you press a button and you stretch it out and you release it. Uh, so this creates a rectangle. You can also create a square in a similar manner, and it's very easy. You just select a starting point and ending point, and to create a rectangle shape objects. And the final we have is freeform curves. Uh, Freeform curves allows for creative and organic shapes. You can create curves by defining multiple points, and the graphic package, it identifies interpolates between the points and it creates a curved, smooth line. Or you can also create a rectangle, let's say in the diagram, and you can stretch it out, and this way you can create freeform curves.
Virtual reality environments are computer generated spaces that users can experience through specialized hardware and software. These environments are designed to simulate real world, providing users with a sense of presence and engagement. Actually, virtual reality date back to the 1950s but gained prominence in recent years. There are three types of virtual realities: immersive virtual reality, augmented reality, and mixed reality. Immersive virtual reality environments features high quality graphics and 3D modeling that closely resemble the real world. The more realistic and detailed the visuals, the more immersed the user feels. There are certain key points in virtual real environments includes virtual world and immersion, sensory feedback and interaction, and etc. Mm, Actually, in actually for virtual reality environments, user will wear the VR headset that was equipped with sensors such as accelerometers and gyroscopes. The sensor detects the headset's orientation and movement in the real time. When you turn your head or move it in any direction, the sensors provide data about these movements, and it will track the position of our head, and it will update the virtual view inside that headset. So user can see that side of the virtual world, and it also contains a real-time rendering. The virtual reality system graphics rendering engine takes the updated view and renders the 3D scene from the new perspective in real time. This means it quickly recalculates the position and angles of all objects in the real world to match your adjusted viewpoint. So, for good virtual reality environments, it should contain low latency. Reducing latency is very crucial in virtual reality to ensure that the virtual world responds quickly to our movements. High quality virtual reality systems aim for low latency head tracking, which minimizes the delay between our physical movement and corresponding update in the virtual environment. And it also maintains high frame rate for smooth and comfortable virtual reality experiences. So, by combining precision head tracking with real time rendering and low latency response, VR systems can create the illusion of being in a virtual environment that closely mirrors our real world moments. This synchronized tracking and rendering process is what enables the user to look around and explore a virtual reality world naturally. And it also contains uh, realistic graphics like high quality graphics and 3D modeling. And um, interactivity is main key element in virtual reality. It's applications like in gamings, and we used in military training, etc. And the virtual reality has input modes like hand controllers, gesture recognition, and voice commands, eye tracking, and body tracking, and etc. Like hand controllers means buttons, triggers, and joysticks. They allow users to perform various actions in virtual reality, such as grabbing objects, pointing, shooting, and navigating menus. And for gesture recognition, it allows user to control the environment through hand and body movements without physical controllers. Users can make gestures like waving, pointing, or forming specific hand signs to trigger actions or interactions in virtual reality. And these virtual reality, some virtual realities also contain voice commands. Like voice recognition technology enables users to control virtual reality experiences by speaking commands. User can give voice commands to perform actions like teleportation, item selection, or navigation, etc. And some virtual realities also contains eye tracking technologies that monitors our eye movements. It can be used for various purposes. And recently, they are experimenting using brain computer interfaces. It's not in the market, but it potentially allows to control virtual reality environments directly through their brain activity. And this choice of input depends on different virtual reality systems. And now we'll see some of few display methodologies of virtual realities environment. There are three types of display methodologies: simulation based virtual reality, and avatar based virtual reality, and projector based virtual reality. In simulation based virtual realities, users are immersed in a virtual environment that simulates, say, specific real world or fictional scenario. These environments are created using 3D modeling. These simulation based virtual reality is used for military trainings and for driving classes, where it allows users to practice skills and scenarios in a risk-free and controlled virtual environment. And we have avatar-based virtual reality. It involves user interacting with a digital representation of themselves or an avatar within a virtual world. Users can see and control these avatars, which often they reflect their movements and actions in the virtual space. This avatar-based virtual reality is used in social virtual reality platforms, online gaming, and collaborative workspaces. It enables users to engage with others, socialize, and collaborate in virtual setting while embodying an avatar. And in projection-based virtual reality, users projectors to display virtual reality content on physical surfaces such as walls or floors. Users often wear 3D glasses to view the projected content, creating an immersive experience without the need of traditional VR headset. And second type of virtual reality is augmented reality. It's a technology that overlays digital information such as images, videos, 3D models onto the real world, and it seamlessly blends the virtual and physical worlds to enhance a user's perception of reality. AR is typically experienced through a smartphone or tablet or AR glasses or other specialized devices. And Pikachu Go game is example for virtual augmented reality. And for mixed reality, Microsoft Lens is Microsoft HoloLens is an example for mixed reality. And main difference between virtual reality and augmented reality is virtual reality is completely 3D images, like it won't show any real world images. It's like we are in different world. But reality overlays the computer generated 3D content in the real world. Like Google Maps, it is creating augmented using augmented reality in future, and the user completely get into new world in virtual reality. In augmented reality, user can interact with the real world also. And in virtual reality, user needs headsets and immersive sound, motion controllers, sensors, etc. But in augmented reality, it is experienced using smartphones, tablets, and AR devices. And augmented reality is partially enclosed, means it contains real world and 3D objects in it. And some well-known technologies in virtual reality are head-mounted display and binocular omni orientation monitor and cave automatic virtual environment. And head-mounted display is a wearable device designed to worn on the head. It typically consists of a pair of small displays, one for each eye, positioned in front of user eyes. HMDs uses lenses to create a 3D effect, allowing users to perceive depth and immersive in virtual environment. And they use sensors like accelerometers and gyroscopes to track the user head movements and adjust the display visuals accordingly, creating the illusion of being inside the 3D space. HMDs, head mounted displays, are commonly used in virtual reality applications such as gaming, simulations, and trainings. And binocular omni orientation monitor, it is a specialized head coupled display system. It typically consists of large helmet with a single display or multiple screens that surround the user's head. The display is a The displays in a boom can provide a wide field of view, giving the user an immersive and all-encompassing visual experience. Users can change their viewpoint by physically moving their head as display responds to head orientation and provides an updated view. And boom technology is used in applications where a high degree of immersion and panoramic visualization is essential, such as flight simulators and certain training scenarios. And the primary difference between HMDs and boom technologies is how they deliver immersive visual experience and virtual realities. Basically, HMDs contains headset, but in boom we have one large helmet like thing. In uh, In HMDs, sensors will track our head movement and adjust the graphics inside that headset. But in boom technologies, we have to physically move our head to see the other sides. HMDs are more portable and user friendly, making them suitable for a wide range of applications, including gaming, simulations, and training. Whereas boom is often used in specialized applications such as flight simulators, and where broad field of view is essential for training. And third type is cave automatic virtual environment, and it is a room-sized immersive virtual environment. It typically consists of multiple large screens or projectors placed on walls, ceilings, and floor of a room. Users enter the cave and wear 3D glasses to experience 3D visuals. Motion tracking systems may be used to monitor the user movements and adjust the visual content accordingly, creating the illusion of being inside a 3D space. Cave provides highly immersive and collaborative environment, often used for scientific visualization, architectural design, and interactive research. And for example, in NASA, they will use cave technology to get the feel they are in Mars or planets. And fourth type is data glove. A data glove is specialized input device designed to track the movements and positions of user fingers and hand in a virtual environment. This glove is typically embedded with sensors and sometimes haptic feedback devices such as vibrators or force feedback mechanisms. Sensors in this glove detect the hand and finger movements, allowing users to interact and manipulate virtual objects through hand gestures. Data gloves are used for applications requiring fine-grained hand interactions such as uh, virtual surgery simulations, architectural design, and controlling virtual interfaces. Yeah.
So the architecture of VR system. VR system has the following components: input processor, simulation processor, and a rendering processor with a world database. So the input processor is basically responsible for handling all input from the user, such as gestures, movements, and interactions. This component is also crucial for translating the user's actions into commands that the VR system can understand. It typically includes sensors, controllers, tracking some of the tracking devices. As we know, like sensors capture various types of input data like motion, position, touch, etc. Controllers are the handheld devices, like you can hold them in hands, that allow users to manipulate objects in the virtual environment and interact with the VR world. Tracking devices such as cameras, uh, they monitor the user's movements, ensuring that the VR system can accurately represent the position, the user's position and orientation in the virtual world. Next, coming to simulation processor, this is basically responsible for creating and managing the VR environment that users experience basically. It simulates a 3D world, the objects in that are there in the VR environment, and various interactions that the users will be doing with the VR environment. The like the simulation process has some elements such as physical engine, AI, scripting, and logic. Like the AI is used to control all the non-player characters, like the other elements in the virtual world, so that the environment will be more dynamic and interactive. Like the physics engine simulates the physical properties of the objects, like such as the object behavior, like how the object has to interact with the user, so that the user will have an immersive experience. This developers usually use the scripting and logic to define how objects and characters behave within the virtual world. Next, the rendering processor. This is responsible for generating the visual and auditory aspects of the virtual environment, just to make sure that they're displayed correctly to the user. So this has like audio rendering engine, HDM integration, and all. So like this graphics rendering engine is basically responsible for rendering 3D graphics like objects, textures, lighting, and any other special effects. This audio rendering handles 3D audio, placing sound sources in the virtual world based on the user's hand movements and basically creating a realistic auditory environment. Next, this world database is a storage and retrieval system that contains all the necessary data for the virtual environment, including 3D models, textures, audio assets, and other resources. Like it basically provides the necessary assets and information to the all the other components of the VR system, allowing them to create, render, and interact with the virtual environment effectively. Like it serves as a storage hub for everything that is needed to make the VR experience better for a user. Next, these are the components of virtual reality. VR hardware is used to produce stimuli to manipulate the VR user sensors. Like these can be worn on body or used separately away from the user. Like they can be handheld, it can be a headset or something like that. So they are basically the sensors to track motions. For example, the when the user button presses and controller movements such as hands, head, and eyes. The sensor contains receptors to collect mechanical energy from the user's body, and the sensors convert this energy which it receives from the hand movement or any other movement, and converts them into an electrical signal. This electrical signal is basically fed into the computer or device for action. The image shows the sensory movement and the respective device associated with it and simulation associated with it. For instance, for audio, we use headset. The drivers will be 3D sound generation, and the simulation will be sound simulation. For speech, it's microphone, and stimulation is speech recognition and interpretation. Likewise, for all the other sensory movements. Next, VR applications in environment. Like VR environments are basically designed to provide a 360-degree view, creating a sense of presence that transports users to different places and scenarios, whether it's like exploring a historical site, diving into an underwater world, or anything. So, like to create a realistic experience to the user. So VR will recreate these experiences. So VR system supports 3D audio, allowing sounds to come from different directions and distances, just like in the real world. This enhances the feeling of being present in the virtual environment. And VR gaming also plays a crucial role in the environment, in the entertainment industry. Like it allows players to physically move, aim, and interact with virtual objects. This level of interactivity enhances the excitement and engagement, making gaming experiences more fun. So, like many other factors, make VR an exciting and promising technology in the entertainment industry. Next, VR applications in medicine. VR is widely used for surgical training and practice, providing medical professionals with a safe and controlled environment to improve their surgical skills. Like, for example, there are surgical simulations. They replicate the look and feel of real surgical procedures. Surgeons can practice and refine their skills in a risk free setting, which is particularly valuable for training and gaining experiences in complex surgeries. VR can be also integrated into telemedicine platforms to perform remote surgeries. For example, surgeons can use robotic systems controlled through VR interfaces to operate on patients who may be located in a different geographical areas. This is particularly useful in situations when a patient requires a specialized procedure and the expertise for that procedure is not available local, like the particular doctor who is expertised in that field is not available locally and has to operate remotely. Like it is also an effective tool for medical education. It allows users, students, and trainees to engage in realistic scenarios without the risks of live procedures. So they better practice in a simulated environment, and then they can understand the risks associated with it in a better way. Next, VR applications in manufacturing. VR allows manufacturers to create virtual prototypes of products and production processes. Like design modifications can be implemented quickly and cost effectively in the virtual space, like without the need for physical prototypes. Uh, Designers can easily make changes to 3D models in a virtual environment, testing different configurations and features. They can be done easily in a VR environment. Like this design process basically ensures that potential issues, like whatever issues that can come later on, can be identified and addressed early in the development cycle, so that there'll be no wastage of time or efforts, or it's or money cannot be wasted. VR eliminates the need for costly physical prototypes, basically allowing manufacturers to save on materials and production expenses. Next, VR applications in education and training. VR driving simulators provide a safe and controlled environment for learning and practicing driving skills. Like learners can experience various road conditions, traffic scenarios, and challenging situations without the risks associated with the real world driving. Like basically, they can simulate emergency situations such as sudden braking, or for example, skidding, or some bad weather conditions, something like that. This allows drivers to practice and develop the necessary skills that are associated with those risks and respond in a better way in real life emergencies. And similarly, we have your flight simulators, and they're used in aviation for pilot training. Like this, it provides like the same how it is providing a driving simulators and vehicles. It provides the same a realistic cockpit experience, allowing the trainee pilots to practice takeoffs, landings, and various risks associated with it in a controlled and safe environment. And similarly, in the ship simulators also, like they're used in the training programs for marine drivers. They can navigate through virtual waterways, practice docking procedures, and learn how to handle different types of vessels, etc. Similarly, we have tank simulators. They are employed in military training for tank crews. They can practice target acquisition or firing in a realistic virtual battlefield environment, rather than on a live ground. Next, user interface. User interface is basically a point of connection between a user and a computer system. It includes all the elements that allows users to communicate with and control the computer. So the primary goal of the user interface is to enable effective communication between the user and the system. Like we have two types of user interfaces. One is character based interface and graphical user interface. A character based interface In a character based interface, the interactions occur through text characters. Like users communicate with the computer by typing commands, or selecting options that are present in a text. Like this is basically found in like command line environments, and so on. GUI uses graphical elements such as icons, windows, buttons, or drop-down menus to like for the user interaction. Like instead of relying on text commands, users interact with the system by clicking or dragging, dropping the elements on the screen. Next, user interface styles. Direct manipulation allows users to interact with objects on the screen by manipulating them, like the same drag, drop, pointing, clicking, something like that. So that is direct manipulation. Touch screens on smartphones or laptops, tablets. This can be an example of direct manipulation. Next, graphical user interface, as discussed in the previous slide, it employs graphical elements such as buttons, etc. Like GUI make computing more visually intuitive, so that instead of text commands, the user can interact directly. And WIMP is an acronym that is used for Windows icons, mouse, pull down menus. It has all these icons for visual representation, a mouse for pointing and clicking, pull down menus for accessing commands, etc. So like Windows OS can be an example for WIMP interface, for example. And next, menus represent a list of options or commands that users can select from. They can be submenus, or they can be hierarchically arranged, or something like that. So these are most commonly found type of interface style. Next, forms or interfaces that present a structured layout for inputting data, like by users basically fill in fields, checkboxes, or other input elements. They're basically used for data entry and submissions, like that. An online registration form, login screens, for example. Next, a command language interface requires users to input commands in a specific syntax to interact with the system. Like it is basically a text-based interface, or a command line, basically used in a command line environment. Uh, Next, character-based interface. In a character-based interface, information is basically displayed as a grid or array of boxes on the screen, where each box is capable of holding a single character, and the arrangement of characters in these boxes like forms a visual representation of the interface. So like users interact with the system by inputting text characters using a keyboard. They are displayed in the corresponding boxes on the screen, and a basis of communication will be formed between the user and the computer. So like the keyboard usually serves as a primary input device for character based interfaces. Like we type using the keyboard. So like whenever you type a particular key, the corresponding key will be displayed on the screen. Next, the display screen is like the output device that presents the array of boxes to the users. As users input characters via the keyboard, the corresponding characters are displayed on the screen. Next, unlike graphical interfaces, character-based interface primarily rely on text characters for output. The screen displays information using a combination of characters arranged in the array of boxes. We have text-based menus, functionality and navigation menus. So as discussed earlier, like text-based menus are presented as text-based options. Like users can navigate through these menus using keyboard commands, using arrow keys, or something like that. And functionality and navigation menus in CB in character-based interface provide a structured way to access different functions or commands. Like users can interact with the menu system to initiate specific actions or navigate through the available options. Next, graphical user interface. The screen is basically divided into a grid of picture elements such as pixels. Like each pixel represents the smallest uh, unit of visual information on the display. The arrangement of pixels forms a visual interface, like incorporating graphical elements such as windows, icons, buttons, or other visual components. The visual elements are used to represent information and facilitate the interaction between user and the computer. Next, the output device will be a display screen. The display screen serves as a primary output device. It represents the visual interface to the user. Uh, Changes in the interface triggered by user actions are immediately reflected on the screen, providing real-time visual feedback. Uh, GUIs basically rely on pixel-based graphics to create detailed and visually appealing interfaces. Next, one significant advantage of GUIs can be like the potential for different programs to share data among them seamlessly. Like common GUI frameworks and standards facilitate interoperability, allowing multiple actions to run concurrently and share information so that the tasks will be performed faster and in a better way. They often incorporate clipboard functionality, allowing users to copy and paste data between different applications. So, it provides a better user computer interaction, and the user's tasks can be performed in a better way and in a faster way. In certain applications, such as design software or 3D modeling tools, users interact with three-dimensional objects. 3D GUIs provide an interface for manipulating and navigating through these objects in a virtual space. And we have monocular and binocular depth cues, which are employed to translate 2D information into a perception of depth in 3D GUIs. Monocular cues such as perspective and shading provide depth information based on the view from a single eye, whereas cues such as stereoposis enhance depth perception by simulating the way humans perceive depth using both the eyes. In summary, a graphical user interface represented by dividing the screen into a grid of picture elements combines visual elements, input from the keyboard, and output to the display screen. And the next will be continued by Pratham.
So screen layout with the windows, menu and icons are the issue is like the layout of the screens, the arrangement of the windows and the menus and icons can significantly impact the user's ability to navigate and understand the system, because as the system goes complex, the user may not able to understand everything because everyone don't know how to use it perfectly without knowing its functionalities. So some of the examples we can say are like the cluttered menus and inconsistent layout. For example, in cluttered menus, if the application is overly complex with menus and submenus and options that are given for the user, it can make it challenging for the users to find the function that they need quickly and to have their function done and to make their work done efficiently by using those menus. And also inconsistent layout means that they have the different screens with software application which have inconsistent windows layouts and icon placements. It can create a sense of disorientation for users. And also one thing we have to keep in our mind is that the icons which we are using for this user interface should be understandable to each and everyone, because it is like wide variety of, it should be like wide range of people will be using these applications. So we need to make sure that everyone understand what is the usage of that icon. And
And also some other examples are like some of the other issues are like windows and icons. The design and the use of these windows and icons in user interfaces plays a major role in usability for the user experience. These windows and icons should be properly designed and enhance the navigation and comprehension. For example, due to unclear icons and overcrowded windows in file management application, the icons don't clearly present the association actions. For example, using a vague symbol for a delete can confuse the users. And when a software application displays too many icons within a window or toolbar, it can make the interface cluttered and difficult to use. Coming to a skill level issue, considering the variant skill level of the users, an effective user interfaces should accommodate both novice and expert users, making the system accessible to the broad audience. Examples are like overwhelming options and limited features for experts. In software that caters to both experts and beginners, overwhelming beginners with too many advanced options upfront can be confusing. And on the other hand, if an application meant for experts lacks advanced features, it might not meet their needs and they might not be able to use it to the full extent. So consistency and memorization are the other issues. Consistency in design is essential for user interfaces. It ensures that users can predict how the system behaves and which makes their interaction smoother and more efficient. And for example, in inconsistent buttons, font and color variations are some of the issues they can be faced while using these type of applications. A mobile app where different screens have inconsistent button placements and color schemes, and users might get confused when the same function is accessed to different buttons on different screens. In a web application, using different fonts and colors for similar functions on various pages can lead to the disjointed user experience. And undo and error handling are the other interface issues where effective error handling is crucial to prevent user frustration. When errors occur, the system should provide clear and informative error messages and guidance on how to resolve the issues. Some of the examples are like generic error messages and no undo option. A sign up form that displays a generic error message without specifying what went wrong when a user enters an invalid email address. And users needed like specific guidance to correct their mistakes and go in the right way to get the correct output from the application. And in a word processing software, if users accidentally delete a paragraph and there is no undo function, it can lead to function. It can lead to frustration that they need to do that and they need to type that whole message and they need to write whole matter again. And other interface issues is like feedback. Providing feedback in user interfaces is crucial, especially for the complex actions. Like users need visual cues and progress indicators or informative messages to understand what the system is doing. So they might know like what will happen next and what they are doing properly. And some of the examples are like lack of progress indicators and ignored user requests. An online image editor that does not show any progress indicator while a complex image filter is being applied, users might think that the system is unresponsive. So they need to get a message that this work is being done and this work is being in the progress. So they might know what is happening in their user interface. And ignored user requests issue is like, for example, an email client that repeatedly receives user requests for a feature but does not implement it over time can lead to user frustration. Like user needs to know if their feedback is considered or not. And coming to the design examples, we need to add graphics design. Graphic design, we need to add the graphic design to our user interface to make users like enhanced. They feel it is like adaptable and make it good while they're using the interface. And the graphic design is the practice of composing and arranging the visual elements of a project, designing the layout of a magazine, creating a poster for theoretic performance, and designing package for a product are all examples of the graphic design. The objective of the graphic design is to convey or enhance a message. Good graphic art streamlines communication. Just pictures a spreadsheet with data analytics. A graphic designer might use different colors to highlight which metrics are rising and which are dropping, thus making it easier for the viewer to quickly understand what's going well and what needs to be adjusted. And well executed graphic design can also elicit an emotional response from the viewer or even motivate them to take action. The sign up page on website, for example, is typically designed to enhance visitors to join an email list or start a free trial. Meanwhile, food packaging design aims to make the food inside seem more appealing to eat, where they can grab where they can grab the attention of the more customers. So the brand using the design is a practice of setting guidelines and best practices for a company to use across all the branded materials to ensure a consistent branded identity. Brand designers help communicate the personality, tone, and core messaging of a company. So these good brand designers have an understanding of marketing design, web design, logo design, and many other aspects of graphic design, because the decisions they make will affect the all subsequent design projects. For that brand work involves a lot of strategy. And marketing design is a graphic design for marketing initiatives. Like marketing designers may work on small projects such as the layout of a promotional email or large multifaceted projects such as designing the booth, handouts, and printing the materials for the trade shows. And web design, many graphic artists work on visual elements that will be used on a website. But it's important to note that web design and the graphic design are different. Like designing a great website is a multidisciplinary undertaking because websites are interactive rather than fixed assets like a brochure or magazine. You need graphic design skills as well as experience with user experience and user interface design, which is why many websites are designed by teams of multiple professionals with complementary skill sets. Infographic design. At their core, infographics are simply representations of data or information that can be consumed visually. Like infographics can come in the form of 2D illustrations, interactive elements on a website, or even videos. The common thread is that they will help the viewer more easily understand the bulk of information or the complex concepts. Here we can see that there is a lunar cycle and sleep, like it is a radical cycle of the moon, which can be explained by you seeing the matter, which is like research. They said that they explain each and every process of the lunar cycle easily, and this can help users or the audience can understand very efficiently. This is the example of like one of the example of infographic design. And coming to this packaging design, from food to gadgets to designer jewelry, the packaging that items are transported in is often just as important as the items themselves. Product packaging designers aim to show off or complement the item inside the packages. Like it is a first impression when the audience or the user receives their package. So we need to make sure the package designing is good enough to grab their attention. And these are some of the references that we use